We've all read of articles about jobs that will be gone in a few years, haven't we? The digital age will be rough for some professions. At the same time, others will thrive. People who can work with data and manipulate it efficiently will be in high demand for many years to come. This is why learning SQL can be one of the best career decisions you have ever made. Wow, this is a bold statement, but it's also true. SQL was one of the most desired programming skills in 2017, even more so than popular programming languages like Java and Python. SQL allows you to be independent at work. You don't need other people to send you data and run queries for you. It gives you the freedom to immediately obtain the answers to the questions you want to ask. And we are proud to present to you 365 Careers SQL course. So far, we've taught over 90,000 students on topics like Excel, statistics, Python, and machine learning. And their feedback and completion rates have been off the charts. I mean, sure, there are many SQL courses available online. So, why choose precisely this one? Here's a few reasons. Business-centered. Most SQL courses are centered on web development. Although the material from this course applies to that field too, our main focus is business application. We teach you how SQL is being used for business intelligence and data analytics. MySQL based. We prepared this course using MySQL, the world's most popular database management system. 9 out of 10 most popular websites in the world use MySQL. Step by step. Our course starts from the very basic and gradually delves into teaching rather complex topics. This allows you to go from beginner to pro. Real-life data analytics. In addition, a large part of our lessons feature the employees database, which is a real-life database containing millions of rows, allowing us to carry out complex operations. Exclusive topics. Finally, this course teaches topics rarely even touched upon elsewhere. Together, we will learn about SQL stored procedures, SQL functions, relational database theory, triggers, sequences, and indexes. This will ensure you receive complete preparation and training. Okay, that's not everything. By signing up and completing the course, you will also receive a certificate of completion that can be posted on LinkedIn, and you will get lifetime access to 2 of our other courses as a gift. Microsoft Excel 2016 Beginner and Intermediate Training, provided you complete the course at 50%, and Advanced Excel Training, provided you complete 100%. Sounds awesome, right? The course comes with a complete 30-day money-back in full guarantee, so you have nothing to lose and everything to win. So what are you waiting for? Click the Take This Course button and let's begin this journey together.
Hello and welcome to our SQL course. I am Martin, and I am a programmer who has spent significant time working with SQL and databases. It is my pleasure to present a course that stands out from the rest of the SQL courses available on Udemy and online. This course is different because we will not repeat everything written in one of the textbooks about SQL and relational databases. Instead, I will provide you with a set of SQL practical tools you will need at your workplace. No useless concepts. Everything is straight to the point and easy to understand. The curriculum we have prepared for you comprises a heterogeneous set of topics data analysts and data managers need in their daily work. SQL allows these professionals to manipulate large sets of data. An advantage of using SQL is its syntax is intuitive, which predisposes you to learn it quickly. You'll first need to internalize the meaning of a few specific terms if you want to grasp the wide scope of its application and the ease with which this language can solve sophisticated tasks. Therefore, in the first part of this course, we will focus on explaining databases, database management systems, and SQL. I have organized the videos so the abstract ideas are easy to understand. No, this will not be a set of boring, theoretical SQL concepts you'll never hear at your workplace. This is precisely the knowledge you need to understand how to work with data, tables, relational database management systems, and their visual representation. Before we start, I would like to ask a favor. Do not skip any of the lectures in the first part. I promise they will help you develop the perfect orientation and logical reasoning required for smooth, high-quality coding throughout the course. After the first part, we'll show you how to set up the software environment you'll need in this course. And you'll be able to roll up your sleeves and start programming. The best part is, you won't just see how you can work with an existing database. We will show you how to create an entirely new database from scratch. That's great, right? Just wait to hear what comes after that. In this course, we will work with a real-world database from GitHub. It is large enough and will give you a good idea of how we can use SQL in real-life situations. It is not a small data set gathered for a beginner's course. I am sure you will appreciate this aspect of the course. We believe this is the right way to learn SQL. Then, after you have learned how to set up a database on your own, you will plunge into the wonderful world of data manipulation. This is the section where you will learn how powerful SQL can be when used for the extraction of information and insights from a database. You'll go through the classical SQL statements, column and table constraints, functions. Then we will cover more sophisticated topics such as joins, subqueries, self-joins, and views. Finally, we'll be ready to learn how to work with some tools professionals love to use, stored procedures and functions. We will conclude the course by learning about a few challenging advanced SQL techniques, such as triggers and indexes. Besides the fundamentals, this course will teach you a solid set of useful topics, tips, tricks, and sharp skills that will give you an edge in the market. I am a firm believer in the statement, the most effective way to learn is by doing. This is valid, especially for SQL, because the difficulty of the tasks you must deal with at work require previous experience. So, please do the exercises attached to the lectures. They will be in the form of quiz questions and will reinforce everything you have learned in the lessons. Should you have any queries, please reach out and write in the Q&A section. We will be happy to answer within 1 or 2 business days. In addition, throughout the course and in my practice, I stick to best practices and clean coding. Remember, a well-organized or good code is not the one computers can understand. It is the one humans can understand. So, what are you waiting for? Dive straight in and let's begin this journey together. So, why study SQL? Put yourself in the shoes of an employee or a manager of a company who works with large amounts of data. For example, you could be working in business intelligence, BI, data science, database administration, or back-end web development. Any of these jobs relate to storing large amounts of data. Therefore, before carrying out any analysis with the data, you will have to retrieve it. As a consequence, the focus of our course is namely on developing the skills required to solve business analytical problems and applying solutions in a software that allows you to extract the desired information from the database. To achieve all this, you need SQL. SQL means Structured Query Language. It is a programming language specifically designed for working with databases. It allows you to create, manipulate, and share data, especially data from relational database management systems. The way to tell the computer to extract information from the database for you is by writing queries in SQL. A query, pronounced query or query, is a piece of code inducing the computer to execute a certain operation that will deliver the desired output. The latter process is called querying the database. Briefly, SQL is the language that allows you to write queries that the computer can execute and then provide database insights in return. The good thing about SQL is it is an intuitive and easy to learn language. Be careful, as this does not mean using it will be a simple task. Not at all. Sometimes the business problems you must solve will be peculiar and will involve the processing of large amounts of data. Despite being relatively simple in its structure, SQL can be powerful while computing very complex tasks. This is why, in this course, we provide the raw skills you'll need to become a web programmer, a data analyst, a data scientist, or a business intelligence analyst. The idea is to combine video lessons and advanced exercises that will show you SQL's cool and fun to work with. And if for some strange reason you are still wondering whether SQL is a programming language worth having in your skill set, let me show you the following statistics. A TechWorm study shows SQL is the most demanded programming language for 2017, in general, not in a specific sector. Indeed.com shared the same information for 2016. Indeed.com also ranks SQL high when related to lucrative job positions. It is true. Sometimes these kinds of studies are indeed biased. So, let's change the question and refer to a study conducted by Stack Overflow. where they asked over 56,000 developers in 173 countries which are the most used technologies. The top three are 1. JavaScript, 55.4%, 2. SQL, 49.1%, 3. Java, 36.3%. Therefore, SQL is a highly demanded skill in the job market, no matter how you look at it. Stay tuned for the next video to understand what it is and why it is the most suitable software environment for this course. Thanks for watching. Okay, so, at this point, you might be telling yourself, great, let me install software containing SQL and start the course. Unfortunately, it is not so simple. Why? To implement SQL commands, you will need a database management system, often called a database or a platform. The problem is, there are a few popular databases out there, which are all based on SQL. They support various forms of the original language, and there are only slight differences between different versions. As a developer, you want to learn how to use the one that is the most suitable for your situation. We will base our course entirely on MySQL, but you should know there are other platforms like Oracle, SQLite, Microsoft SQL Server, PostgreSQL, MariaDB, Microsoft Access, and so on. The minor differences between the versions of the SQL language mean that transferring from one database to the other, which usually happens if you are changing jobs, would not be an obstacle for you. If you are a user of another platform, you can still take this course and easily apply the tools we teach. So, why do we choose MySQL? Because it is reliable, mature, and open source. The latter means it is free. It is used by many institutions and companies, including Facebook, YouTube, Dropbox, Twitter, Pinterest, Booking.com, and LinkedIn. Considering the well-renowned DB Engine's ranking, MySQL comes as the first open-source relational database management system. Yes, Oracle is on top with only a slight advantage, but don't forget, it is a paid software. Therefore, aiming at providing you with the best experience possible, we chose MySQL. Now, let's dig into some database and SQL theory. This will provide the set of tools you'll need when we deal with various SQL tasks in the lessons to come. Thanks for watching. One thing you'll notice when studying programming languages is that the concepts you encounter are interrelated. This means focusing on a single topic can hardly deliver the content that must be explained in its entirety. To this story, SQL makes no exception. Despite that, we must start from somewhere, right? My working experience tells me you will be much faster in learning and writing efficient queries if you go through a brief introduction to databases. It is the best thing to begin with, so here's what I would like to share with you. The table you see here contains data about the customer sales of a furniture store, and this is how we should read this information. Purchase number 1 was registered on the 3rd of September 2016. Then, customer number 1 bought the item with code A1. Each of the 4 elements has a specific meaning. We will call each one a data value. All 4 data values make up one record. A record is each entry that exists in a table. It corresponds to a row of the table. Therefore, these 4 data values form one record, and these data values regarding purchase number 2 form another record. You could use the terms row and record interchangeably. Besides the rows, you can see the data is separated into 4 columns or fields. A field is a column in a table containing specific information about every record in the table. This means all the records in a table, regardless if they are 10, 10,000, or 10 million, will have a certain purchase number, date of purchase, customer ID, and item information. When the data you have is organized in rows and columns, this means you are dealing with stored tabular data. That is important to mention because you will often see in the literature that database management relates to data stored in tabular form. Great. Here comes the more interesting part. In this table, we know nothing about a customer besides her ID. The information about customers is stored in another table called Customers. There are several fields, such as first and last names, email address, and the number of times customers have filed a complaint in our store. So, what would the logic of that structure be? Every time we have a customer with an ID number 1 in the sales table, we can refer to the customer with ID number 1 in the customers table and see her name, email, and number of complaints filed. Same goes for the items table. It contains the item code, product description, its unit price, ID, and name of the company that has delivered it, and the company's headquarters phone number. Here, the connection between the sales table and the items table is not the customer ID, but the item code. Well, we could stuff this information into one table, and it would look like this. Ouch! It is huge. I would not want to imagine what the table would look like if we had registered over 10 rows. My point is, there are too many columns, and it is hard to understand what type of information is contained in the larger table. Relational algebra allows us to use mathematical logic and create a relation between a few tables in a way that allows us to retrieve data efficiently. Namely, these three tables, sales, customers, and items, are related through the customer ID or the item code columns and form a relational database. And, importantly, each one bears a specific meaning and contains data characterizing it. One of the tables contains information about sales, the other about customers, and the third about the items. To recap, remember the data values in a row form a record in a table, and each column represents a field that carries specific information about every record. A few related tables form a relational database. And for those of you who are interested in slightly more technical definitions, remember the smallest unit that can contain a meaningful set of data is called an entity. Therefore, the rows represent the horizontal entity in the table, the columns its vertical entity. The table is a bigger data entity on its own. It can also be referred to as a database object. A single row of a table, being a single occurrence of that entity, can be also called an entity instance. Okay, great. We will gradually build the theoretical preparation you need before you begin coding. Stay tuned for the next lecture, where you'll see SQL's role when working with relational databases. Thanks for watching. All right, let's shift gears. What is the first thing that comes to your mind when you hear the word database? For many people, this question is more challenging than it might seem at first. An answer like a big file where much information is stored is not satisfactory and would not please potential employers. You should remember there are two main types of databases, relational and non-relational. The former will be the focus of this course, while the latter regards more complex systems. Although understanding non-relational databases requires a serious mathematical and programming background, some of the logic applied in its coding is the same as SQL. Likewise, relational databases have a few advantages on their own. A small bit of theory will explain why they are still the preferred choice in many companies and institutions. Databases' main goal is to organize huge amounts of data that can be quickly retrieved upon users' request. Therefore, they must be compact, well-structured, and efficient in terms of speed and data extraction. Today, people need such extra efficiency because data occupies memory space, and the bigger its size, the more sluggish the database is, and the slower the retrieval process becomes. If we have a database containing one multi-million row table with many columns, then every time a request has been received, the server must load all the records with all fields, and it would take too much time for a task to be completed. Don't forget, every symbol is a container of information and requires bytes of storage space. Hence, loading that much data will not be an easy job for the computer. So, what allows us to contain so much data on the server, but lets us efficiently use only the portions we need for our analysis? The secret lies behind the use of mathematical logic originating from relational algebra. Please don't worry, we will not bother you with math. Imagine each table with data is represented by a transparent circle that contains all the data values of the table, categorized by columns, or as we will often call them, fields. Now, if our database consisted of only one table, a giant circle would represent the entire database. Something like this huge table from our fictional example with the sales database. And when we need a piece of information from the database, for example, if we wish to see who has bought something on a certain date, we will have to lift the whole big circle and then search for what we need. This challenge seems vague, and the process of data extraction will not be efficient. See what can happen if we split the circle into 3 smaller circles, just as we did with the sales database. One circle will stand for the sales table, the other for customers, and the last one for items. There are various theoretical combinations between 3 or more circles, but in our database, we have the following model. Sales and customers have the same customer ID column, and sales and items have the same item code column. This way, we can see the circles overlap as they have common fields. So, if we'd like to extract the same information, the name of the customers who have purchased something on a given date, we will need only the date of purchase column from the sales table and the first and last name from the customers table. So, to satisfy this request, we will not need to lift the third circle from our database, items. This way, we can save energy, or more technically, increase efficiency. Less data, represented as only 2 of the 3 circles, will be involved in this operation. The mathematical trick lies in relating the tables to one another. Relationships were formed namely through these common fields. More explanations about this technique will be provided in our next lectures. Anyway, I am sure that now you understand why we use the term relational databases. Some professionals may refer to the tables or the circles in our plot as relations because theoretically, they are the smallest units in the entire system that can carry integral logical meaning. Likewise, the 3 circles are all part of our sales database. When we combine the database and its existing relations, we obtain the famous term Relational Database Management System, frequently abbreviated as RDBMS. We hope this theoretical illustration makes things clearer. SQL is designed for managing relational database management systems and can do that by creating relations between the different tables in a database. Stay tuned for the next lecture, where we will outline the most substantial differences between a database and a spreadsheet. Thank you for watching. Welcome back to our SQL course. In this lesson, we will talk about the differences between databases and spreadsheets. But first, I'd like to ask you a favor. I would be really grateful if you could go to the course dashboard. That's easy to do. All you have to do is click here and leave a rating for the course. This will mean a lot to me and will help other students know that this course is worth taking. The reason I am asking you to do this now is that this is a large course, and most people do not complete all the lessons in one sitting, eventually forgetting to leave a rating. So, please do it now. It should only take a couple of seconds, and it will really validate our efforts. Thank you so much for this. Okay, now, having said that, let's continue with the comparison between databases and spreadsheets. Okay, great. Now, we understand why people use databases. However, I would imagine some of you are Excel users and still imagine an Excel spreadsheet when we talk about tabular data. Please, don't do that. Data tables, databases, and Excel spreadsheets are different things. In this lecture, we will focus on the differences between spreadsheets and databases. This exercise will be relevant not only for current Excel users. Those of you who do not use Excel regularly will still have the chance to understand the advantages and the disadvantages of using databases or spreadsheets. Okay, let's start with the definition. What is a spreadsheet? It is an electronic ledger, an electronic version of paper accounting worksheets. It was created to facilitate people who needed to store their accounting information in tabular form digitally. So, it is possible to create tables in a spreadsheet. This is one reason some people believe spreadsheets and databases are interchangeable, while in reality, they aren't. There are similarities between the two. Both can contain a large amount of tabular data and can use existing data to make calculations. Third, neither spreadsheets nor databases are typically used by a single person, so many users will work with the data. The differences between the two forms of data storage lie in the way these 3 characteristics are implemented. Okay, imagine a spreadsheet. Every cell is treated as a unique entity. It can store any type of information: a date, an integer value, a string name. And then, not only can we have different types of values in various cells, but we can also apply a specific format to these cells. This is not inherent to databases. They only contain raw data. Each cell is a container of a single data value. It is the smallest piece of information there is. You must preset the type of data contained in a certain field. This feature prevents inadvertent mistakes. For example, in a field containing date values, should the user try to insert a string, the software will show an error and she will have the chance to correct herself. This won't happen in Excel. If you insert a string in the column with date values, you wouldn't obtain an error message, and Excel will store the string value. In a spreadsheet, data can be stored in a cell, while in a database, data is stored in a record of a table, meaning you must count the records in a table to express how long the data table is, not the number of the cells. And that is it. You cannot pick a font color or size. All you care about is the information being stored. You don't care about formatting. Our main goal is to save the numbers. Another substantial difference is that in a spreadsheet, different cells can contain calculations, such as functions and formulas. This means if you want to combine two integers, the result will be stored in another cell. In a database, all calculations and operations are based on the existing data and are done after its retrieval. There is a specific feature called views, similar to the tables, in which you can do a calculation. These objects also contain columns that can be normal columns like the ones in the tables, or could contain a certain type of calculation. There is no way you can mistake a record of data with a calculation. The database features mentioned so far improve data integrity. You can't store different types of data in the same field. And it is unlikely someone will mistake a data value for an outcome of a calculation, especially in large data sets. Data integrity is a strong advantage when working with databases. Naturally, you might think a spreadsheet can contain multiple worksheets, so one can create tables in the worksheets, and then use the worksheets to create relations between the tables. Why bother using relational databases? Well, in a spreadsheet, such relations will be logically limited. Instead of setting up spreadsheets or worksheets, one can set up relations between the tables, and this will boost the performance of operations, increasing the speed with which you could manipulate your dataset. Albeit powerful for many circumstances, spreadsheets have their limitations. Excel is incapable of handling over 1 million rows of data. This immediately induces us to look for a solution. Usually the fix is to use databases, where having 2, 5, or 10 million records is not a problem. Referring to the multi-user property, spreadsheets are lagging. Essentially, every person must update their own spreadsheet with new data. For instance, if there is a new purchase to register or a last name in the customer's table to correct, every user must make these changes manually. You would justifiably think Google Docs and the latest version of Office solve this issue. But they do so only partially. In Google Docs, you might have trouble finding out who changed or deleted information incorrectly, which often leads to a cumbersome situation where people have a hard time organizing their tasks. As opposed to that, you saw in the Data Control Language lecture that databases provide a stable structure, controlling access permissions and user restrictions. One person can make a change that is visible to everybody instantly. This feature increases efficiency and data consistency when using databases. Considering data integrity and data consistency, using databases eliminates duplicate information, which is another way to save space and increase efficiency. Look at the customers table. You know a certain first and last name corresponds to a unique email address. So, if you know John McKinley has changed his email and you are using a spreadsheet flooded with data, you may change the email address once and accidentally miss updating the same address in another record. This may lead to inadvertent mistakes. They can be avoided when using a relational database. An accredited user only needs to access the customers table and change John McKinley's email address there, just once. Not only will this operation save time, but it will also anticipate inconsistencies. So, what we discussed in this lesson are highlights why databases are a better environment for storing and keeping track of data when working with multiple dimensions and large amounts of data. Spreadsheets have their advantages as well. They are an excellent tool that allows us to carry out extensive analysis. But for the easy retrieval and updating of data, efficiency, data consistency, data integrity, speed, and security, relational databases are definitely the structure to opt for. They can store lots of raw data and are excellent when separating the data from the way it is displayed for analysis. As you saw, it would be a good idea to stop trying to visualize data tables in the form of spreadsheets. They are different. Stay tuned for the next lecture, where we will offer more database terminology. Thank you for watching.